What is the statement? Let f be a function, f be continuous on closed interval AB and differentiable on open interval AB. Clear? It says there exists a point C in the open interval AB, that is between A and B, such that what is f dash C is equal to FB minus FA over B minus A. So in Rolle's theorem, there were one more condition that FA is equal to FB. In mean value theorem, if FA is not FB, then there exists a point C such that f dash C is equal to FB minus FA over B minus A. If you take FA is equal to FB, then mean value theorem implies the Rolle's theorem. So what is the geometrically, suppose you have a xy plane, x and y, and you have this type of curve. Suppose this is A and this is B. The value of at A is FB and FB. It says if it is continuous and differentiable, there exists a point C. The tangent at C will be parallel to the chord joining A and B, FA and FB. This is the geometrical interpretation that in Rolle's theorem, there exists a point C. The tangent at that point will be parallel to the x-axis. Here, there exists a point at which the tangent is parallel to the chord joining FA and FB. So this is the geometrical interpretation of mean value theorem. Now, mean value theorem is an important tool for the calculus. With the help of this, if you know the property of f dash derivative, then we can see the effect of this property on f. If you know something about f dash, so you can draw some conclusion on f. So let us see with the help of some examples. Example 1. Suppose let f is a function from AB to R be differentiable.
Sir, your voice is lagging.
So you are not audible.
It will come. Now it is coming. Then f. No, it is connected. तो है. Now my voice is coming or not now?
Sir, yes, it is coming.
Yes, sir.
Sir.
Yes, sir.
Then f is constant if and only if f dash x is equal to 0 for all x is the element of AB. You know this result, but with the mean value theorem you can solve it. It means you know about f dash is equal to 0, so you can tell about the f will be constant. So with the help of knowing something about f dash, you can draw some conclusion on f. So I am proving let f be constant on AB. So by definition, So by definition of differentiability, f dash x is equal to 0, because why? Limit x is tend to c fx plus h minus fx over h. So this is 0 constant. Now conversely, let f dash x is equal to 0 for all x is the element. You can see not x, you can take any other point, because I will write fk for all k is the element of AB. This is given. Now you need to prove f is constant. So how you can prove? Let you have any point b x which lie between a to b. So f is differentiable. F is differentiable. F is differentiable on can I write ax, because it is given that f is differentiable on AB. So x is point between A to B. So by mean value theorem, there exists a point C between A to X such that what will be f dash C fx minus fa over x minus a. So here you can write fx minus fa. This is f dash c x minus a. This is into multiplication. X minus a, where a is less than c is less than x. But from 1, f dash k is equal to 0 for all point between a to b. So you can write fx minus fa is equal to 0 since f dash c is equal to 0 from 1. So here fx is equal to a. So it means x is arbitrary. You can take any point. This is f, which is equal to a. So you can say f is constant. So you can see that if f is differentiable, so then f dash s is equal to 0, then f is constant. Let us do one more problem. Suppose f is continuous. This is given on closed interval a b and differentiable it says if f dash x is not equal to 0 for all x is the element of AB, then f is 1 1. So it means you know about f dash x, you can conclude something about f. So if you want to prove f is 1 1, so how can you prove? You can prove there are two ways. Fx is equal to fy if. So you can say x is equal to y. Or you can prove if x is not equal to y, so you need to show that fx is not equal to fy. So let this is given. Okay. let x and y are element of AB, okay, and x is y less than y. One will be less than. So now clearly f is continuous on closed interval xy because x and y are element of closed interval AB and f is continuous on closed interval AB and f is differentiable on open interval xy. So by mean value theorem there exists C lie between x and y such that how f dash c will be fy minus fx over y minus x. So here you can write fy minus fx. This is f dash c into y minus x. Suppose this is 1. Here f dash c is 0. So can you write fy minus fx? This is not equal to f dash c is equal to 0, 0 or y minus x is not equal to 0. So this is not equal to 0. F dash x is equal to 0, not equal to 0 for all x is the element of AB and y minus x is positive. So this is you can say fy is not equal to fx. So f is 1. So you can try many things. Suppose example, if you take in above example, if
Sir,
if
over there sir, one doubt.
yes,
Sir, over there you've taken f dash c equal to 0.
no, I am not taking second example. F dash x is not equal to 0.
No, no, sir. What have you done in the step labeled 1? Sir,
In
sir, the step that you have marked as 1, first step.
which example?
So this one only that we are doing. You have marked as 1, right? Where f dash c equal to fy minus fx upon y
Yeah,
minus
maybe
x. No, sir,
this
below.
one. Ah,
Sir, he is talking
yes.
about the equation one you took
Equation
in
1.
this
Yeah.
example.
So what is the problem?
Sir, how did you go from the sir?
I'm not getting
How
your
did you
point.
go from
Right on
equation number
the
1 to the next step, sir?
this is fy minus fx is f dash c y minus x equation 1.
Okay, sir, but
इसके बाद
after that.
after that क्या बोला f dash c is not equal to
Sir,
0.
I can't hear you, sir. Sir,
Sir,
आपकी
voice
आवाज
is
ये
lagging.
पॉइंट पे नहीं है तो
Sir,
सी पे भी नहीं होगा y is the
voice is
minus
lagging.
distinct from x so this will not be equal to just wait.
Sir, voice is lagging.
Am I audible now?
Yes, sir.
Yes, sir.
Sir, can you
Yes,
please
sir.
explain once again?
I am saying if f dash c into y f dash c this is given that f dash x is not equal to 0 any point so c is a point between a and b so f dash c cannot equal to 0 y minus x is y is x is greater x is less than y so y minus x cannot be equal to 0 the product of two non-zero number is non-zero so it cannot be 0 clear
Yes, sir.
any other doubt so now come to the Cauchy mean value theorem, CMVT. This is known as Cauchy mean value theorem. What is the statement? It says let f and g be continuous. Mute your mic, Mudit Chaudhary. Continuous on closed interval AB and differentiable on open interval AB. And after that, suppose this g dash x is not equal to 0 for all x is the element of AB. G dash is not becoming 0. It says then there exists C between A to B such that what says f dash C over G dash C is equal to FB minus FA over GB minus GA. So this is the Cauchy mean value theorem. It says if you have two functions f and g which are continuous on closed interval and differentiable and derivative of g dash x is not becoming 0 at any point, then there exists a C which satisfy this condition, equation 1. So with the help of Cauchy mean value theorem, you can prove many inequalities. A lot of equalities. One equality I am proving. So that 1 minus x square by factorial 2 is less than cos x for x is not equal to 0. This is actually when you are applying the Cauchy mean value theorem,
Your voice
you
is
need
lagging.
to find fx gx. So here, अरे यार,
Your voice is lagging.
now just wait. Internet. Now it is coming.
Yes, sir.
Yes, sir.
Okay.
Yes.
So now main problem in this you need to you need to find f and g. It comes from the normally practice. Fx you take 1 minus cos x and gx you take x square by factorial 2, that is x square by 2. Why am I, if you take g dash x, so it will not become 0. Let interval be 0x. So now f and g are continuous. On this interval, f and g are differentiable. On open interval, and g dash x, which is x, is not becoming 0 for x is not equal to 0. So, by Cauchy mean value theorem, there exists C lie between 0 to x such that there exists C. This is what is f x minus f0 over gx minus g0. This is sine c over c. Okay. Now here you can write 1 minus fx, 1 minus cos x. I think this will be x gx. This will be c. X square by 2 is equal to sine c over c. So whatever be the value of c, this is less than 1. 1 minus cos x is less than x square by 2. 1 minus x square by 2 is less than cos x. So here you can prove this inequality. For minus you can prove yourself. Another you take minus x to 0. Clear? Minus x to 0, another interval, continuous differentiable, and apply mean value theorem. Again you will get the answer. So here you can do for minus x to 0. So here you can do yourself. So this is the Cauchy mean value theorem. Now come to the next point, that is the local maxima or local minimum. So all of you know definition of this. I am writing first definition, then geometrically I will tell you after completing definition. It says let I is the subset of R be an interval f from I to R be a function first definition. It says a point C element of I is called local maximum, yeah, some books maxima, if there exists delta is greater than 0 such that how fx is less than equal to fc for all x is the element of delta minus c, sorry, c minus delta to c plus delta. So a point is called local maxima if value of the function at that point is maximum among all the points in the neighborhood of C. If you go left hand side and right hand side, the value of the function will be maximum in the neighborhood of C minus delta C plus delta. This is the neighborhood. Same definition, a point C element of I is called local minimum या minima if there exists a delta is greater than 0 such that here this is the value of the function at C will be minimum among all the points which lie in the neighborhood of C. Minimum, or a point C is called local extremum. Local extremum, yeah, extrema, if it is either local minima or local maximum. So now point is, here we are discussing local maximum minimum, but if you take an interval, what is the absolute maxima or global maxima? It means little bit different. Local maxima we talk about the neighborhood, but absolute maxima, this is the a point is called absolute maxima. The value of the function at that point is maximum in the whole domain. That is, I am giving the complete definition.
Excuse me, sir.
Yes.
सर ये इधर लोकल मैक्सिमा और लोकल मिनिमा के पहले क्या लिखा है?
If it is
ओके सर.
So your screen is lagging.
Sir, your voice is lagging and screen has frozen.
is called local
Sir, your voice is lagging.
Sir, your voice and screen is lagging.
Okay, correct.
Sir, you are not audible.
Now, yeah, just wait. Now my voice is coming.
Yes, sir.
Okay. So now definition. Let D is the subset of R and F is a function from D to R. Okay. I'm giving the definition of global maxima or minima. A point C element of D is said to be absolute maxima. Yeah, in some books it is written as global maxima on D if what is FC is equal to, if it is finite we write supremum, otherwise maximum, fx such that x is the element of D. The meaning of the supremum, at point C the value of the function will be maximum among at all the points of D. Same thing, a point C element of D is said to be absolute minima या global minima on D if this fc is equal to infimum, minimum value of the function at all points in the domain D, and a point C is called global extrema if it is either global minima or global maxima. So let us do one geometrically. Let us see. Suppose you have this type of picture. So here these are there are this is a function f. There are some points, suppose c1, this is c2, c3, c4, c5. So here what it says, global local maxima. So this is in this neighborhood, c3 is local maxima. Here this is c5 is local maxima. In the neighborhood it is maxima. Here c1 is local maxima. But here c2, if you take in the neighborhood of c2, the value of the function at c2 is minimum. So this is local minima. Again, this is local minima. So you can write c1, c3, c5. They are local maxima, while c2, c4 they are local minima. Now suppose you have this interval. This is interval. So what is the absolute maxima? From figure you can say c1 is the absolute maxima and c4 is the absolute minima at all one. So you can say c1, this is absolute maxima, and c4, this is absolute minima. So I think, is it clear what is absolute maxima or minima? Now you can say the local maxima or local minima should be the interior points. Local maxima or minima, because you take the neighborhood. So neighborhood is both sides. So you can note local maxima or minima should be interior points. So now you have studied the minima or maxima. What is local maxima? What is local minima? Absolute maxima, absolute minima. Now let us check necessary condition. You know this condition, necessary condition for local extrema. It means local maxima or minima. So definition say necessary condition. This theorem says let you have a function from I subset to R to R. I be an interval. If f is differentiable. First, it should be differentiable at any point. C is the element of I and has a local extremum. Then f dash c is equal to 0. Normally, when you apply the condition, when you check local maximum minima, you put f dash x is equal to 0 or find the point. So it says there is two condition. F must be differentiable. Second is you must be confirm that f has a local maxima or minima. Then f dash c will be 0. If there may be chance when f dash x is equal to 0 at some point, but that point is not local maxima or minima. How? Let us see two example. Example 1. Suppose let you have a function from R2 to R such that fx is equal to minus x square. So here, this is a polynomial. Clearly, f is differentiable. Okay. You are checking at x is equal to 0. And if you see the quotient f is equal to minus x, can you say about local maxima or minima? Yes. At x is equal to 0, it will have local maxima. And f, from geometrically you can say f has local maxima at x is equal to 0. You are confirmed. Then you can see then f dash 0 x. This is minus twice x. So f dash x at 0 will be 0. Here you have confirmed that it has a maximum because minus x square minimum value will be the 0. Now,
So, but why differentiality is necessary? Like in the example, y equals to mod x.
wait. अगर डिफरेंशियबिलिटी नहीं देख रहे हो तो f dash x डिफरेंशिएट कैसे करोगे? If it is not differentiable, you cannot find f dash x. Clear?
No, sir. Like in the example, y equals to mod x. We have
Yes.
local minimum, global minima.
Yes.
So, but it is not a differentiable function.
Yes.
So, but
What
you
you want
told,
to say?
sir, but you told us that differentiality is the necessity condition.
What I am saying, you are not understanding. I am saying if you have these two conditions, I am not saying differentiability is the necessary condition. I didn't say. If ये then के बाद जो है this is the necessary condition. वो कह रहा अगर if this is differentiable and has a local extrema, if these two condition are given, then f dash c is equal to 0. then के बाद जो होती है वो necessary condition होती है. अगर डिफरेंशियबिलिटी नहीं है तो ये मैं कह नहीं सकता. हो भी सकता है नहीं भी. But if these two conditions are satisfied, compulsory it will be happen. Like mod x, f is not differentiable, so it may have, but इसे डाउट है. थ्योरम इज नॉट जनरली प्रूफ. अगर ऐसा है तो डेफिनेटली होगा. आर यू गेटिंग पॉइंट? डिफरेंशियबिलिटी इज नॉट नेसेसरी, वो नहीं कह रहा. अगर ऐसा है डिफरेंशिएबल है देन एंड एफ डैश इज डिफरेंशिएबल और लोकल एक्सट्रीमा तो एफ डैश वैल्यू ऑफ द डेरिवेटिव विल बी 0. अगर डिफरेंशिएबल ही नहीं है तो एफ डैश एक्स की कोई बात ही नहीं है. तो necessary condition is f dash c is equal to 0, not differentiability. Is it clear?
Yes, sir.
So now let us see this example. Let you have a function from R to R such that fx is equal to x cube. Here f is differentiable, but you cannot say by any other method that f has a local maxima or minima. And at 0, you are not conform. The second condition of necessary condition is not guaranteed you. You are not 100% sure that it will have. But f dash x, if you find 3x square, this is 0, x is equal to 0. This function is becoming x is equal to 0. So you can say that f has a local maxima. But no. This function does not have local maxima. This is like that. So it means what is the converse of this is not. It means what is the? It may be a chance that value of the derivative of function becomes 0 at any point. It may or may not be the local maxima, because this is a necessary condition, not sufficient condition. Clear point?
Excuse me,
If
sir.
anybody else,
माइनस एक्स स्क्वायर लिया है. अब सर जैसे माइनस एक्स स्क्वायर, सर माइनस एक्स स्क्वायर काफी सिंपल फंक्शन है, हमें उसका ग्राफ भी पता है, तो हमने बोल दिया कि उसके पास लोकल मैक्सिमा होता है. पर सर अगर कोई कॉम्प्लेक्स फंक्शन आता
होता ही नहीं है.
सॉरी सर आपकी
होता
आवाज
ही
ला.
नहीं. Am I audible now?
यस सर.
Yes, आर्यन. उसके पास होता ही नहीं है.
जैसे मैं कह रहा था माइनस एक्स स्क्वायर के पास हमें पता है कि ग्राफ से हमें ऑलरेडी पता है कि लोकल मैक्सिमा होता है, तो हमने लिख दिया
हाँ.
कि इट हैज अ लोकल मैक्सिमम एट एक्स इक्वल टू 0. सर ऐसी कोई अगर कोई कॉम्प्लेक्स फंक्शन आ जाए जिसका हमें ग्राफ ना पता हो और हम
Wait. Actually, why I give this example, minus x square, you can geometrically observe that this has a local maximum because 0, then it is becoming. I am showing the necessary condition. Now, you are asking, sir, if function is complex, so what we do? Question is this. Is it clear? Now your question is, what we do? If function is not so easy, so what we do? There is another condition that is known as sufficient condition. Come into the picture. So it means you have what it's saying, if f dash x is equal to 0, then you cannot say that it will have local maximum minima. So what other conditions should we add so that we can solve a complicated problem also? So I am doing sufficient condition. This is second derivative test. This is known as.
सर
Yes.
सर एग्जाम्पल 2 में हमने प्रूफ किया है, मतलब कि सर एफ एक्स डिफरेंशिएबल.
Just wait. I prove this is possible that the value of the derivative at any point becomes 0. But it doesn't mean that that point will be the local maximum or minimum. ये जरूरी नहीं है, कन्वर्स ट्रू नहीं है नेसेसरी कंडीशन का.
ओके सर.
डिफरेंशिएबिलिटी कंटिन्यूटी. तो what it says, let C be any interior point of interval. Let f is a function defined on I to R. This is if f is twice differentiable. Okay. if f is twice differentiable at C and satisfies f dash C is equal to 0, then we have what we have. See, f dash x will be 0. In necessary condition, if f dash c is equal to 0, you cannot say. But if f dash c is equal to 0, find point and f is twice differentiable. If one of the following condition is satisfied, then you can say it has a local maxima or minima. What is first? Then if f double dash c, because this is differentiable, f double dash c is greater than 0, or you can say in some book we write f double dash c is equal to 0. It means greater than 0 means local minima. Local minima, yeah, you can say f dash c change sign from negative to positive in the neighborhood of C, left to right. Then f has a local minima at C. F dash double dash C is less than 0, or f dash C change sign from positive to negative. Then f has a local maxima at C. Third point, if f double dash C is equal to 0, no conclusion can be drawn. Need further investigation. Yeah, you can write further investigation is needed. So you can see in this second example, here if you take f double dash x is equal to 0. So again, this is 6x, or f double dash 0 is equal to 0. So this is third case. So you cannot say anything. So what is the necessary condition? I am combining both. If f is differentiable and you are confirmed that f is local maximum minima at any point, then value of the derivative of function at that point will be 0, but converse is not true. So when converse will be true? Converse will be true if f dash x is becoming 0 at any point and function should be twice differentiable. Now find the value of twice differentiable function f double dash x at point C. F double dash C, if this is greater than 0, so you can say C point will be the local minima. If f dash double dash C is less than 0, then f has a local maxima. So if anybody has doubt, now ask me. Is it clear?
Yes, sir.
तो अब मुझे लगता है अब डाउट नहीं होगा. Okay, let us do one example. Suppose you have a function fx is equal to sin x and 1 plus cos x. Find local extrema. So first find f is twice differentiable because sin x cos x are twice differentiable. So find f dash x. F dash x, if you solve cos x 1 plus cos x plus sin x or minus sin x. So f dash x, this will be cos x plus cos square x minus 1 plus cos square minus sin square x minus 1 plus cos square x. This is 2 cos square x plus cos x minus 1 for local extrema. It should be 0. F dash x is equal to 0 twice cos square x plus cos x minus 1 is equal to 0. So if you solve this, this is coming 1 plus cos x twice cos x plus 1 is equal to 0. So what will be x from here? I think pi. X is cos x is minus 1 by 2. I think 2 cos minus आएगा. So this is pi by 3. So now what is f double dash x? You find f double dash x. If you find this is coming, I am writing directly. You can find 4 cos x plus 1. So at pi, f double dash pi, this is coming. No conclusion can be drawn. Oh, sorry. At x is equal to pi by 3. So f double dash pi by 3. So minus sign, I think minus, please check the value, root 3 by 2, 2. So this will be 2 cos pi by 3, 1 by 2. I think it is coming 3. So this is minus 3 root 3 by 2, which is less than 0. So f has minus, I think, local maxima. Maxima at x is equal to pi by 3. So this is the question on local maxima. If anybody has doubt, ask me. No? Okay. So now you have some